So one of the nice things about scientific notation is that when it comes to multiplication and division, now we can use some of our exponent rules to help us do some very large looking multiplications. We know that if we really were to rewrite these numbers and look at the multiplication that we had to handle, were they not in scientific notation, we would have 2,400,000, right? Because we shifted our decimal place from 1, 2, 3, 4, 5, 6 places to the right, times 0.000000123456015 places to the right, right? We're being asked to multiply these two, right? Look at all those zeros. What do we do with all of that? It's very confusing. However, in the scientific notation, it's not so bad. Why? Well, this coefficient is multiplied by the number, but remember, in our associative property of multiplication, we can multiply any two pieces of this direct multiplication together if we want. So this could actually be treated as 2.4 times 10 to the 6th times 1.5 times 10 to the negative 8th, which is to say we could treat our coefficients separately, multiplying 2.4 times 1.5 and multiplying that by the result of our multiplication for our exponentiated numbers, 10 to the 6th times 10 to the negative 8th. What does that mean? Well, right here, these two are really easy to handle, right? 10 to the 6th times 10 to the negative 8th is going to be the same thing as 10 to the negative 2. Take a moment, go back to your rules, and look at why. Right? A to the m times a to the n is equal to a to the m plus n, and it doesn't matter if the base is 10. We don't multiply the 10s together. We just take that base as a and we add our exponents together. So this is really like saying 10 to the 6th times 10 to the negative 8th is 10 to the 6 plus negative 8, right? Pretty cool. All we have to do is just add those two guys together and we've got it. All right. Okay, so what do we do now? Well, we've got 2.4 times 1.5. We are going to have to handle that multiplication, but it's a little bit easier than having to deal with all these zeros hanging out all over the place, right? So let's take 2.4 times 1.5. How do we handle that? Well, don't forget, in decimal multiplication, we're just going to go ahead and handle the multiplication as if the decimals weren't here, and then count off 2 decimal places from the end after we're done. So 4 times 5 is 20. We know that. 2 times 5 is 10 plus 2, 12. Put a 0 placeholder here, and the 1s now go 4 times 1 is 4. 2 times 1 is 2. When we add these two together, we get 0, 6, and 3. Moving the decimal place over twice gives us 3.6. So our result right here is 3.6 times 10 to the negative 2. Pretty good. All right, let's look at our next one down here. We've got 4.8 times 10 to the 12th divided by 3.2 times 10 to the negative 5th. Again, wow, it seems like a big complicated thing, but it really isn't. We can treat each of the coefficients separately from our basis. So we could treat this as 4.8 divided by 3.2 times 10 to the 12th divided by 10 to the negative 5th. Now we can handle this division separately for our coefficients from this division of our exponents for 10, right? And we know the rule for this one too, right? We're using the rule that says a to the m divided by a to the n is the same thing as a to the m minus n power, only in this case we've got 10 to the 12th divided by 10 to the negative 5. We don't divide the 10s as long as the bases match. We just subtract the exponents and make it 10 to the 12 minus negative 5, which is really the same thing as 12 plus 5. So that's 10 to the 17th. So we already have our exponentiated number for 10. All right, 4.8 divided by 3.2. Now, again, because you've got the decimals, many of you will be thinking, all right, 4.8 divided by 3.2. All right, I'm just going to have to do a long division with decimals. Well, remember that the decimal, if we move it over to the right in the numerator, we can move it over to the left. So it's really equivalent to saying 48 divided by 32. Right? And this fraction actually shares some common factors. Can you see it? Yeah, I see it too. Right? They're both, let's see, the top one is definitely divisible by 8, isn't it? Right? 48 divide by 8, what do you get? That's right, 6. And of course, 32 divided by 8 is 4. Well, that wasn't big enough, right? Because that can actually be reduced a little bit more. That's 3 over 2. Oh, that's a lot easier, right? As a decimal, we know 2 goes into 3, well, once. Giving us 2, subtract 1, bring down the 0, 0.5, and of course that divides evenly, giving us a remainder of 0. So what we really have right here is 1.5 times 10 to the 17th. That's the answer that we would be interested in looking for. So we're done. Good luck on your assignments.